We've discussed covalent bond polarity as defined by differences in electronegativity of 0.5 or greater and less than 2. Molecules can be polar too, but molecular polarity depends on geometry. Bond polarity plays a role in molecular geometry, but geometry and symmetry are far more important at this level. Just because a molecule has polar bonds does not mean it will be a polar molecule. For example, carbon dioxide and carbon tetrachloride are non-polar molecules, even though their bonds are polar. Because of the high symmetry of these molecules, the bond polarities cancel one another out, and there is no net charge separation or polarity. Non-polar molecules must have a very high symmetry and specific geometry. To determine whether a molecule is polar or not, we look to symmetry. Highly symmetric molecules are nonpolar, while low symmetry molecules are polar. Highly symmetric molecules must meet two criteria. The outer atoms must be the same element, and there cannot be any lone pairs on the central atom. There are some examples of highly symmetric molecules which have lone pairs, but they are outside the scope of this class. For us, these two criteria must be met. If a molecule is diatomic, then there is no central atom. However, a diatomic molecule is polar if the bond is polar, and a diatomic molecule is nonpolar if the bond is nonpolar.